So, this is the again tutorial class, tutorial 5, based on the lectures starting from 21st to 25th, based on this. So, let us see few problems we will discuss. So that the sequence Sn is not Cauchy, hence is not convergent. The sequence Sn where Sn is 1 plus 1 by 2, 1 by 3 plus 1 by n. So, we have to show this sequence is not a Cauchy sequence, hence it is not a convergent. So, Cauchy sequence means a sequence is said to be a Cauchy, a sequence un is said to be Cauchy of real number is said to be Cauchy if for given epsilon greater than 0 there exists a capital N depending on epsilon such that mod of un minus um less than epsilon for all nm greater than equal to capital N. So, if it is not Cauchy, it means we cannot get the difference of any two terms of the sequence after a stage n is less than epsilon. So, let us start with modulus of Sn minus Sm, and suppose n is greater than, start with where say n is equal to say 2m greater than m. Start with this. Okay. So, what will be the Sn minus Sm? So, Sn minus Sm, this will be equal to S2m minus Sm, and which is equal to 1 over m plus 1, m plus 2 up to say 1 by 2m. So, this will be greater than. Now, the smallest term is 1 by 2m. So, this is greater than 1 by 2m into 1 by plus 1 by 2m up to n m terms. So, 1 by 2m. So, this is m over 2m, which is half. So, what we get is Sn minus Sm is greater than half, whatever the n and m may be large. So, it cannot be. So, if we choose m epsilon to be half, then we cannot find an h. There does not exist an n such that mod of Sn minus Sm less than half for all nm greater than equal to n. So, this shows it is not a Cauchy sequence, and we know if a sequence of real or complex number, if it is Cauchy, then it must be convergent. So, since it is not Cauchy, therefore, it is also not convergent, because of every Cauchy sequence of real complex number is convergent, because every Cauchy sequence of real or complex number is convergent and vice versa. So, this result we have already discussed. So, this shows that. Now, exercise. So, we can now take a few problems. Suppose we have contactive sequence, we can just drop. Okay. Consider the sequence n into minus 1 to the power n. Test the convergence of the sequence. Convergence of the sequence. I think it is a simple part. What is the sequence? If we look the sequence comes out to be -1, 2, -3, 4, minus 5 and so on. So, we are getting a sequence subsequent 2, 4, 6 and so on, which diverges to infinity. Minus 1, minus 3 is also diverging to minus infinity. Therefore, this is a unbounded sequence, hence diverges, hence not convergent, not convergent. So, that is very simple part for it. We will not go in detail for it. Okay. Exercise. Use the Cauchy criteria of convergence. Cauchy criteria of convergence to prove that sequence yn is convergent, where yn is 1 plus 1 by factorial 2, 1 by factorial 3 and so on, 1 by factorial n. This is okay. So, what is the criteria of convergence? Cauchy convergence criteria means every Cauchy sequence of real complex number is convergent, or a sequence an of real or complex number is Cauchy if and only if it is convergent. That result is, so we will use this result to prove that it is a Cauchy sequence, hence convergent. So, now let us see what is our factor. First, see 1 by factorial n. This is basically 2, 3 up to n. 1 is of course okay. Now, each term is less than 2. So, 1 by 2 to 2. So, can we say this is strictly less than 1 by 2 to the power n minus 1? Is it okay? Because 3 is greater than 2. So, 1 by 2 is greater than 1 by 3 and like this using. So, use this thing, we now have by m minus by n, where m I am choosing greater than n. So, this is equal to 1 by factorial n plus 1 factorial n plus 2 up to 1 by factorial m. This is the same as less than 1 by factorial is less than 1 by 2 n. Just now 1 by factorial n is less than 1 upon 2 to the power n minus 1. So, it is less than 1 by 2 n. This is less than 1 by 2 n plus 1 and this is less than 2 to the power m minus 1. So, from here we can say 1 by 2 n if we take outside, then inside we get 1 plus 1 by 2 plus 1 by 2 m minus n minus 1, okay, and that will be equal to limit 1 by 2 n geometric series 1 minus half raised to the power m minus n term over 1 minus half, and that becomes half 1 by 2 n into 1 over 1 minus half h. This is 1 by 2 n, because this is less than 1 minus 1 is less than 1 and this is equal to 1 minus half. So, total is 1 by 2 n minus 1. So, y m minus y n is less than 2 n minus 1. Therefore, since 1 by 2 n minus 1 goes to 0 as n tends to infinity. So, we have for every epsilon r greater than 0, there exists an n naught belonging to capital N such that 1 by 2n minus 1 is less than epsilon r for all n greater than equal to n naught. Therefore, by m minus by n is less than epsilon r for all m n greater than equal to n naught. This is true for all n, hence by m is a Cauchy sequence. Therefore, by n is also convergent sequence. Okay. So, that is what is proving, is using this only we are proving for this. Okay. Next exercise we see, so that sigma n is 1 to infinity n to the power n divided by factorial n cannot converge. Now, these are the terms of positive terms, series of positive terms, and if a series is convergent, then nth term must go to 0. But if all the terms of the series are positive and limit of the nth term n does not go to 0, then series has to be divergent. So, here n is n to the power n by factorial n. These are all terms are positive, and the limit of n as n tends to infinity, this will be what? This is basically limit of this as n tends to infinity, n into n up to 1 divided by 1, 2, 3 and then n. So, this is n by n is greater than 1, n by 2 is greater than 1, n by 3 is greater than 1. So, basically this limit will always be greater than 1, whatever the n may be. Therefore, the limit of this does not tends to 0, as n tends to infinity is not equal to 0, while all the terms, hence the series sigma of this thing n to the power factorial n 1 to infinity divergent. Clear? Because of the we are using this result, a series of positive terms. If in a series of positive terms, the nth term does not go to 0 as n tends to infinity, then the series will be divergent. So, this is our okay. So, using this we can go for this. Next is, so that the sequence x n defined by x n is equal to 0 to n cos t divided by t square dt is Cauchy. So, let us suppose m is greater than n. Suppose m is greater than n, then mod of x m minus x n. this is equal to mod this is 1 to sorry this is 1 to n, because otherwise t equal to 0 the function will not be defined. So, 1 to n. So, 1 to m cosine t over t square dt minus 1 to n cosine t over t square dt, and that will be equal to modulus n to m cosine t over t square dt. But this is less than equal to integral n to m mod of cosine t by t square dt, but cosine is bounded and bounded by 1. So, it is less than equal to integral n to m dt by t square, and this is integrable, the value will be minus 1 by t and then within the limit n to m. So, this comes out to be minus 1 by m plus 1 by n, which is strictly less than 1 by n at this is negative side. So, as n tends to infinity, but since limit of this 1 by n as n tends to infinity is 0, then so for every epsilon greater than 0, there exists an n naught greater n naught depending on this epsilon such that for any number, for any n greater than equal to n naught, we have mod of x m n minus x n, which is less than 1 by n less than epsilon, and this is true for all. Therefore, the sequence x n is a Cauchy sequence. Cauchy sequence. Okay. So, this is so because the right hand side is less than epsilon, therefore, this will go to this. Okay. The next exercise, let x n be a sequence such that there exists a greater than 0 and c belongs to 0 1, for which mod of x n plus 1 minus x n is less than or equal to a into c to the power n for any n greater than equal to 1. Then so that x n is Cauchy, secant x n is Cauchy. Okay. So, let us see the solution for it. Suppose m is greater than 1, m is greater than n. Consider mod of x m minus x n. This is less than equal to mod x m minus x m minus 1 plus mod of last term x n plus 1 minus x n. This term we are writing. Now, each one use this result. So, this is less than equal to a c m minus 1, a c m minus 2 and so on, and last term is a c n. So, take a c n common. So, when you take a c n common, you are getting 1 plus c square up to c m minus n plus 1. Now, this is a geometric series and the sum will be 1 minus c to the power m minus n divided by 1 minus c. So, this will be strictly less than further a over 1 minus c into c to the power n. Now, c lying between 0 and 1, because it is given c belongs to 0 1. So, c lies between 0. Therefore, this implies that limit of c n as n tends to infinity is 0. Hence, for given epsilon r greater than 0, there exists a capital N naught such that modulus of c n minus 0 is less than epsilon r for all n greater than equal to n naught. Therefore, this sequence x m minus x n is less than epsilon r for all m n greater than equal to n, and this shows the sequence x n is a Cauchy sequence. Cauchy sequence for okay. So, this will be our Cauchy sequence. Exercise 6th. So that the sequence n plus minus 1 to the power n divided by n is not a Cauchy sequence. Not a Cauchy sequence solution. So, let us start with say epsilon r is 1/3. If I prove that difference x m minus x n is greater than 1/3, then it will not be Cauchy sequence. So, let m is suppose n plus 1. Then what will be the x m minus x n? This is equal to n plus 1 plus minus 1 to the power n plus 1 divided by n plus 1 minus n minus 1 to the power n by n, and that gives you 1 plus minus 1 to the power n plus 1 by n plus 1 plus 1 by n. Now, take the two cases when n is even and when n is odd. So, when n is even, you are getting, when n is even, what we are getting is x m minus x n is nothing but greater than equal or is equal to 1 minus 1 over n plus 1 plus 1 by n, which is greater than equal to 1 minus 1 over 1 plus 1 plus 1, because this will be n plus 1 is n is greater than 1. So, 1 by n is less than, but with minus sign again it is greater than. So, this shows this is greater than equal to 1 minus 3 by 2, which is half. So, this part is m, and when n is odd, then x m minus x n will be equal to 1 plus 1 by n plus 1 plus 1 by n, which is obviously greater than 1. So, in any case, this difference is not less than 1/3. Therefore, the sequence x n is not a Cauchy sequence. Is not a Cauchy sequence. Okay. So, next question is 7th. If u n is greater than 0 and sigma u n is convergent, with some s, then prove that u n over u 1 plus u 2 plus u n is strictly less than 2 times of u n by s. see the proof for it. Where n is sufficiently large, where n is sufficiently large quantity, n is sufficiently large quantity. So, solution is, now since sigma un is convergent, sigma un is convergent with the sum S. So, for given epsilon, greater than 0, there exists a positive integer m such that the difference between Sn and the sum S is less than epsilon for all n greater than or equal to capital N, where Sn means the sum of the first n terms of the sequence. So, this implies that Sn lies between S plus epsilon and S minus epsilon, and in particular, if we take epsilon to be half, then what we get, half of S, epsilon is half of S, which is positive, then half of S is less than Sn, is less than 3 by 2 S, and this is true for every n greater than or equal to m. So, this implies that 2 by S is greater than 1 by Sn, is greater than 2 by 3 S, 3S, and but S in this one un by S is, so 2 by S is greater than this, and therefore, what we get from here is, can we say un over Sn is less than 2 un by S. Multiply this, okay. So, multiply by un here, so un by Sn is less than 2 by un Sn, and this shows, this implies that un over S means Sn means S1 u1 plus u2 plus un. This is strictly less than 2 times of un by S, and that is what we wanted to show. Is it okay? So, this complete. Thank you.